So this video is about the Riemann Zeta function. This is the definition of the zeta function. Zeta of S is equal to the sum from n equals 1 to infinity of 1 over n to the s power. Now let's look at some specific values of the zeta function. So zeta function of 1, well, it's just the sum of from n equals 1 to infinity of 1 over n, because to the first power. So this is just 1 plus 1/2 plus 1/3, so on and so forth until infinity. This is also known as the harmonic series. And this is known to diverge. So there's no finite value for it. It's infinity. Now, for the zeta function of 2 would be the sum of 1 over n squared. So it's basically 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, and so on and so forth. Now this does not diverge, in fact converges to pi squared over 6. And this was proved by Leonhard Euler. And when he proved it, he solved what was called the Becel problem, which is basically people knew it converged, but then they didn't know if you could find an exact analytical solution to it, the zeta function of 2. And next you have the zeta function of 3, which is like 1 over 1 cubed plus 1 over 2 cubed up to infinity. Now this value, people know that it does converge, but then all they've known is that it just they can only numerically figure it out. So it's like 1.202 something, and this is known as this value is known as Abre's constant. So this is just like the Becel problem, which people have they know it converges, but they don't know which value, if there's an analytic solution to it. So this is still an unsolved problem in mathematics, because people don't know the exact solution to it. And finally, you have the zeta function of -1. Now this is just the sum of 1 over n to -1, which is just the sum of n. So that's 1 plus 2 plus 3 plus 4, etc. Now this just diverges. But then sometimes it's convenient just to say it equals -1/12, and this is used in other fields such as string theory. It's very counterintuitive, but that's how it is.